Alright, this review goes through a lot of different things. The first thing up is partial fraction decomposition. Then at the end is integration by parts, and in the middle are some kind of simpler things that are just randomly thrown in here that are integral properties and finding the area under a curve, or finding an integral graphically by finding the area underneath a curve using geometry. So we'll go through each of these, and it should be a pretty fun time. So starting off with partial fraction decomposition, these first two problems say to just set the problem up and not to solve for the constants, which means if you start actually trying to solve for A and B and things like that, you've gone too far. What we want to do is think about the denominators that it takes, or that are possible if we end up with a common denominator of x squared and x plus 1 squared. Well, obviously we have to have x squared and x plus 1 squared. But the other things that we need that we have a habit of forgetting of, because a lot of times we just try to break those up, is that it could be that there was a denominator that just had an x. And it could be that there is a denominator that just has x plus 1 without the squared. And so we have to have both an x by itself and an x squared, because those are the two possibilities that come together to get x squared. X plus 1 and x plus 1 squared, that's the two possibilities that come together to get x plus 1 squared. Now, all of these things are linear or linear to a power. Like this is x, and it's being raised to the second power. And so because of that, all of these just need a single letter on top. So A, B, C, and then D. Then we want to look at the next one and see what the difference is. These are not linear. These are both quadratic, and we can't split them up. You can't factor x squared plus 4, and you can't factor x squared plus 2. And the reason that's important is that means that it's possible that once we've broken these up, that the top of our fraction could end up having an x on top. So we have to put ax plus b. And then we have to do x squared plus 4 squared. And that has to have two new letters, so like cx plus d. And then we're going to do the same thing for x squared plus 2. So just a regular x squared plus 2. And then an x squared plus 2 squared. And so I guess gx plus h would be my next letters. It doesn't matter what letters you use, like A, B, C, D, E, F, G, H. Sometimes you'll see people use the same letter over and over again, but with a little subscript to show the difference between them. It's really up to you, whatever you are most comfortable with, but that is the idea on both of those. Now, kind of switching pace, we're going to find some integrals. These are things that we could end up with answers. Like this could have been combined into one fraction, and maybe we had to do partial fraction decomposition to get either of these. And so we need to know how to solve them. So what's important is whether or not there is a power on the bottom or not. Because like these both have powers, but this and this and this, none of those have powers. And when we don't have powers, but we have an x on bottom, that is a natural log. So the integral of 1 over something ends up being the natural log of whatever's on the bottom. Now, there's a kind of a chain rule thing happening there in a way, because if the bottom of this is u, what we have to do is we have to think of this like u substitution. U is 4x minus 1, and so du is 4. And that means we're doing 3 divided by 4 to get what's in front of our natural log. And then inside of our natural log is u, which is 4x minus 1. Now, you can just, if you want to just remember that this is what ends up in front of your natural log, that's 3/4, that's fine, as long as we don't have like a squared down here, because if we had a squared, then that would make u substitution actually be a lot more necessary, because then it'd be 8x right here, and it'd make the whole thing more complicated. But for now at least, if you just have a number on top and something with an x on bottom, you can take those. Like here, I can do 8 over 2, and I should have a minus 4 in front of this natural log. And then we put plus c because this is an indefinite integral, and we always put plus c at the end of indefinite integrals. On this next one, same kind of thing is happening on the first one. This would be like 3 over 1, and so we'll have 3 natural log of x plus 1. But these other two are not natural logs because we have powers that aren't 1. This would be like a x plus 1 to the first power, which is a natural log. But when it's squared or cubed, what we need to do is think about it like it was on top. And then use the power rule. So we're going to add a power, which gives us -1, and then we're going to divide by that power. If the x plus 1 had a number in front of x, we would have to divide. We'd have to say 7 divided by whatever that is. But since that's just a 1, then it's fine. So that means that when I rewrite this, I'm going to move the x plus 1 back down to the bottom, and now it's going to be to the first power. So this is -7 over x plus 1. I need to apparently rewrite that. And then we're going to do the same thing with this x plus 1 cubed. We're going to move it to the top, use the power rule so that we have x plus 1 to the -2 over -2. 4 divided by -2 is going to give us a negative and a 2 on top. So we're going to move the x plus 1 back down to the bottom with a positive squared, and then plus c. And so the thing that happens is if this is going up in power on the denominator, then if it doesn't have a power, it switches to natural log. But then these that do have a power, they end up going down a power. So it was squared on bottom, now it's x plus 1. But then also you're dividing by negative of whatever that power is. Like this ended up being a first power, and so we had to divide by a negative. This one is a 2, so we ended up dividing by a -2. So that's how that works. All right, now let's actually do some partial fraction decomposition. And the very first step we do is we break up our fraction, our denominator, into what we need, like what we did on 1 and 2. And so our first fraction I'm going to put as x plus 3. Our second one I'm going to put as x minus 2. And then we need to actually figure out what a and b are. So we want to first pretend like we're getting common denominators. So I'm going to multiply the first fraction by x minus 2, because that's what the denominator would need to get back to this original denominator. I'm going to times the second one by x plus 3. And then because if we do that, we end up with all the same denominators, we're going to drop them so that we have 6x minus 7 equals a times x minus 2 plus b times x plus 3. Now there's two different ways to go about this. One way is to distribute a and b and then put 6x together with, in this case it'd be ax and bx. You do 6x equals ax plus bx. You do -7 equals whatever the other two things are, and then that's a system of equations you can solve using like elimination or something like that. The other way to do it is to pick things for x that we can plug in. For instance, I can pick for x to equal 2 and then plug it in, and what happens is that right here my a will cancel because 2 minus 2 equals 0. That's why I picked 2, was because I knew that would happen. And so aside from 2, the other thing we can pick that will help us is -3, because it'll make this part be 0. So this is 12 minus 7, which is 5. The a cancels, and then we have 5b. So we divide both sides by 5 and get 1 for b. Then we're going to plug in -3, I'm sorry. So 6 times -3 minus 7 equals a times negative 3 minus 2 plus b times negative 3 plus 3. So this time the b cancels, and we have negative 18 minus 7, which is negative 25. Negative 5a, divide both sides, and you get a is 5. So we write our answer here at the end by putting 5 over x plus 3. Make sure you put a over the right denominator. So 5 over x plus 3 plus 1 over x minus 2. And that's our answer. Because all this asks us to do is find the partial fraction decomposition, and that's what this is. We're breaking our original fraction up into its pieces that can come together to make it happen. So on 6, if we have x minus 4 squared, our two denominators are x minus 4 and then x minus 4 squared. And so on top of these we need a and b. A on one, b on the other. And this is the thing that can trip you up. We don't need bx plus c on top because x minus 4 itself is linear. The squared's on the outside, so I don't need bx plus c. The common denominators for this also trip people up. All we need is to multiply the first fraction by x minus 4. You don't need to multiply it by x minus 4 squared because it already has an x minus 4, and this is what we're trying to get to. If you multiply it by x minus 4 squared, then you're getting a denominator of x minus 4 cubed. And that's not what this has as a denominator. B doesn't need anything because it's already got its common denominator. So we have 3x minus 20 equals a times x minus 4 plus b. This is a good one to distribute on. And so I'll show you how that works. And some teachers don't like the first method at all. So some teachers prefer that you do this way all the time. So then what I want to do is match up x's from the left and x's from the right. Because if 3x has to equal ax, that means that 3 has to equal a. There's no other number I can put in for a that will give me a 3x. And then I can do negative 20 equals negative 4a plus b, because neither of those have an x. And so they are ending up as regular numbers that add together to get negative 20. So we're going to do negative 20 equals negative 4 times 3 plus b, which gives us negative 20 equals negative 12 plus b, which gives us negative 8. So a is 3 and b is negative 8, so that's 3 over x minus 4 plus, or actually minus, minus 8 over x minus 4 squared. And so if you're wondering, well, how do I know if it's a plus in between instead of a minus? Or how do I know that it's not a minus? The minus comes from if your answer is negative, you'd put a negative in between them. Or you could put a positive and put the negative on top if you wanted to. Whichever. This next one is definitely the toughest of the three because it has the most letters involved. And so before now we only had to solve for a and b, which means we only had the possibility of getting a 2x2 system of equations. Now we're going to end up with 3 variables because we have a over x minus 3, and then the x squared plus 3 needs a b and a c. We're going to get a common denominator, so the first one needs x squared plus 3, the second one needs x minus 3, and we are going to have to FOIL, or we might want to FOIL this, so that does both of those do need parentheses. So we're dropping the bottom of the fractions, a x squared plus 3 plus bx plus c, and x minus 3. Now what we want to do is decide if we want to distribute in FOIL or plug in numbers. The problem with plugging in numbers is we only have one good number to plug in, which is 3. And so after we pick 3, we'd have to pick random numbers basically, and then end up with a system of equations. If we distribute and FOIL, we're going to end up with a system of equations. It actually is easiest if you do a combination of the two. If you go ahead and say, well, plugging in 3 will give me a letter, or hopefully it'll give me a letter. So negative 4 times 3 squared minus 2 times 3 minus 42 equals, it's going to cancel out the second part, so we'll just have a times 3 squared plus 3. If we work out what this is, man, this looks like a lot. This is negative 4 times 9, which is negative 36, minus 6 minus 42. That's 9 plus 3, which is 12a. So this is negative 42 and negative 42, which is negative 84, which is divisible by 12 and gives us negative 7. And then we kind of shelf that for a little while and go back and say, okay, let's go ahead and distribute and FOIL so that we can get our other answers, our other numbers. So this will be negative 4x squared minus 2x minus 42 equals ax squared plus 3a. Then we're going to FOIL here, so bx times x is bx squared. Bx times negative 3 is negative 3bx. C times x is cx. And c times negative 3 is negative 3c. And at any point along the way here, we can put in a is negative 7. I'm going to wait because I think it might actually confuse you if I don't. We want to put the x squareds together so that we have negative 4x squared equals ax squared plus bx squared. Well, what that means is that I can drop the x squareds and say, well, hey, negative 4 has to equal a plus b. Because basically it's like we have like terms that are adding together to give us negative 4. Well, since we already know what a is, we can plug that in and do negative 7 plus b, add 7 to both sides and get that 3 is b. If we didn't know what a was, then we'd have to shelf this to use with our system of equations that's showing up here. Now let's do our x's. So negative 2x equals negative 3bx plus cx. We're going to drop the x's out now because it's like terms. Negative 2 equals negative 3b plus c. Well, since we know what b is, we can plug in and figure out what that is. So negative 2 equals negative 3 times 3 plus c. Negative 2 equals negative 9. So c is 7. Which I'm not super confident about, so I'm going to look and see if that's really the answer. Sorry, it helps if I look at the right problem. Yeah, okay, that is right. So, if we didn't solve and get negative 7 before we started this, we would have this equation that has a and b, we'd have this equation that has b and c, and then we would have kept going and gotten negative 42 equals 3a minus 3c. And so that is a system that has 3 variables. And so one way to do it, you can use elimination, where you're adding 2 of them together to try to get rid of a variable. Or what I did whenever I worked this out the first time is I solved this one for either a or b, I don't remember which, and then I plugged it into whichever one of these equations had that letter. Like you can solve for a is negative b minus 4, and then you can put it in this equation and then distribute and work out what that would be, where it ends up having a b and c, and then use that together with this one to eliminate. So it's a lot easier, I think, if you go ahead and find one of your letters the other way and then use the other method. So a was negative 7, so negative 7 over x minus 3. B is 3 and c is 7, so 3x plus 7 over x squared plus 3. That is our answer. Now we're going to do the whole shebang. The whole point of this is that in order for us to integrate something that looks like this, we need to break it up, because if this was FOILed out and had 2x squared and we tried to use substitution, it's not going to work out. So we want to start this off by doing partial fraction decomposition, where we've got a over 2x minus 1 and b over x plus 5. And we're going to get our common denominator and then set all our numerators equal, drop the denominators. So negative 10x plus 27 equals a times x plus 5 plus b times 2x minus 1. You can solve this either way, and they're about the same length and difficulty. If you distribute, you're going to have a system of 2 variables. If you plug in numbers, you're going to have to plug in negative 5 in either a random number, or you can plug in 1/2, because that's what makes this parentheses equal 0, which you can figure out by setting it equal to 0 and solving. I chose to do this just by plugging in. So if I plug in negative 5, I get negative 10 times negative 5 plus 27 equals a times negative 5 plus 5 plus b times 2x. I forgot to put the negative 5 right there, and that's where it really mattered. So this is 50 plus 27, which is 77. This cancels. This is negative 10 plus 1 minus 1. That's a minus right there. Negative 10 minus 1, which is negative 11, so that's negative 11b. We divide by negative 11 and get that b is negative 7. Then we are going to solve, and you can use like 0 and plug in b as well, or you can use positive 1/2. And it depends on which, like, how much you like fractions or don't like fractions. So negative 10 times 1/2 plus 27 equals a times 1/2 plus 5. And then we're going to, well, our b cancels, so that's good. So negative 10 times 1/2 is negative 5, and negative 5 plus 27 is 22. Then this is 5.5a. 5.5a. Well, at first that may be like, oh, 5.5, surely that doesn't go into 22. But it does. It goes in 4 times. And the way I know that is because 5.5 times 2 is 11. 11 times 2 is 22. So what I've ended up doing is timesing by 4. Anyway, a is 4. Now, what that means is that we just broke this up into 4 over 2x minus 1 minus 7 over x plus 5. This is like problems 3 and 4 where we're trying to integrate this. And so these are both natural logs. You have to think about what this is if you divide it, or use substitution or whatever. So that gives you 2 natural log of 2x minus 1. And then if we do the same here, that's just still going to be 7. So negative 7 natural log of x plus 5 plus c. Now, the only time we need plus c's is when you have this symbol right here and there's not numbers at the top and bottom. If there were numbers, of course, we'd plug them in. But if you don't have this symbol, there's no reason whatsoever to put a plus c at the end of your answer. But if there is an integral symbol, we should have a plus c. Now we're going to change to a different topic. Graph the integrand and use areas to evaluate the integral. So if you're not so great with graphing, what we're doing is basically saying y equals 1/2 x, which your calculator will do. There's no y-intercept. Well, our y-intercept is 0. And then we're going to go up 1 and over 2. And it's helpful the more precise you make this. And we need to be thinking about, we're going to do this from 0 to 6. So I at least need to be here at 0. And I need to go at least as far as 6. And then I can draw my line. And I want to find the area of what's underneath this graph and is in between 0 and 6. So this part right here that I'm coloring. If you think back to geometry, you should recognize that this is a triangle. And hopefully you remember that the area of a triangle is 1/2 base times height. Our base is 6 and our height is 3. So we're going to do 1/2 times 6 times 3, which gives us 9. And that's our answer. 10 definitely looks weird. And so this is a circle. It comes, or a semicircle actually. It comes from a formula that looks like this. This would be a circle centered at 0. If we want to solve that for y, we have to subtract the x squared over and then square root. But when we do that, if we want the whole circle, we'd have to have a plus and a minus sign in front. And so since it's only positive, that means this is a circle with a radius of 2, but it's only the top half of it. And so it looks something like this. Well, yeah. And then you're going to shade underneath and say, all right, well, how do I find the area of a semicircle? Which may seem kind of complicated, but we want to think about that like an actual circle. A circle is pi r squared, and so half a circle is 1/2 pi r squared. The radius of this, whatever number this is, if you square root it, that gives you the radius. So this is 1/2 pi times 2 squared. There's two ways you can write this. You can say 1/2 times 4 is 2, so this is 2 pi. Or you can type in 1/2 pi times 2 squared and get the decimal, which is 6.28. You don't need to put both, but you need to put one of those. Oh, an absolute value. If you're using a TI calculator and you don't know where to find the absolute value bars, you go to Math and you press the right arrow button, and it's the very first option that says ABS. And so if you needed to, you could graph y equals ABS of x. It's going to show you that that's a v. Since there's not a number inside with x, it's just a normal v that goes up 1 and over 1 both directions, which is kind of hard to do when you're drawing with a tablet thing, so forgive me for it not being perfect, if you don't mind. But anyway, so we're going to draw our graph, and then what we care about is being between -3 and 8. So -3 is right here, and then 8 is right here. And so what's happening is we're going to find the area of this and this. And so that's two triangles of different sizes. So this first triangle, the base and height are 3. So we're going to have 1/2 times 3 times 3. Second one is a base and a height of 8. So 1/2 times 8 times 8. This first one gives us 4.5. The second one gives us 32. And since both of those are part of the area, we add them together and get 36.5. This has to do with the properties of integrals. If you're given an integral and you're given numbers like these and what it equals, there's only certain things we can do with that. One thing is that no matter what, if these numbers are the same, then that means we have 0. Because if you integrate and then plug in 5, since we're going to subtract, that gives you 0. The biggest property that we tend to see with problems like this is if you reverse the numbers, instead of 4 to 6, it's 6 to 4. what that does is it makes your answer negative. So the answer for this part is a -4. Another big property has to do with if we have the same function in two different integrals, and between the two, we're covering a bigger spot. Like this is -3 to 5. This is 5 to 9. Well, if this is a continuous function, that means that together we can get -3 to 9, all the way from where the first one started to where the second one ended. And so we do that by adding them together. So 5 plus 6 equals 11. This next section is kind of like supposed to be a review of some things, because all of this is stuff we've done, but it's also like a precursor to what we're about to do with integration by parts. If you're given u, you're going to take the derivative so that you can find du. If you're given dv, you want to find v, so that means you're going the opposite direction, which is an integral. So we have to remember things like, how do I take the derivative of something with a power? Well, that's the power rule for derivatives, which is to multiply by the power and then subtract 1 from the power. So if I multiply by the power, that's 3, and then I subtract 1 and get 3x squared. And then we can put dx next to that, because together the du and the dx are talking about the derivative. So here, if I want to know what the derivative of secant is, I either have to have that memorized, or if my teacher is nice enough to let me have like a formula sheet for these, then I would look on my formula sheet. The way the formula sheet that my class uses is that we have the integral of secant u tangent u du equals secant u plus c. The way this works is, since we're not doing the integral of u, we're doing the derivative, you look backwards. You look for where the right side is secant, and your answer is what's on the left side. And these are all u's, but we're using x here, so we would use x here and here. Now here we have some integrals. Integrals, if we have an x or a number, is the power rule for integrals, which is the opposite of the power rule for derivatives. We're going to add 1 to our power and then divide. And so v would be x to the second power divided by 2. And since we took the integral, you could put plus c right there. Be a pretty good idea. 17, this is like, people get so tripped up with this. If you move this to the top and try to use the power rule, when you add a power, you get x to the 0. And when you divide by 0, you can't do that. And so that all has to do with the fact that the integral of 1 over x is the natural log of x. Again, if you're allowed to use a formula sheet or something on this, that's a formula. The integral of 1 over x is always going to be the natural log of x. And so don't get confused and take the derivative or do something super weird. It's just ln of x. We're integrating secant squared, so you want to know, if you're memorizing these, you probably think about the derivatives and then think backwards, like the derivative of tangent is secant squared, and so that means that the integral of secant squared is tangent. If you're using a formula sheet, you would just match up the integral of secant squared with tangent and move along. The derivative of e to the x and the integral of e to the x are the same. E to the x is easy because it's just e to the x again. And it wouldn't matter if this was dv, we'd get the same thing. If u is 4, and you're taking the derivative, remember the derivative is slope. So this is a horizontal line at 4. What's the slope of that? It's 0. It has to do with the fact that it's like there's an x to the 0 power here. We're multiplying by 0 then, and that's what gives us 0. You can put dx next to there, or you don't have to, because 0 times dx kind of makes that go away. And then if I take the integral of a number, it doesn't become 0. It does the opposite. we're going to think of this like x to the 0. We add 1 and get x to the first, and then divide by 1. So this is 3x. Now, good old integration by parts. Let me think and see if I can remember how this starts. You do u dv. The integral of u dv is the problem they start with. This right here starts off as the integral of u dv. And if you're not given u and dv like these problems are, your first step is to come up with what u and dv should equal before you do anything else. And then the rest of the formula, this right side, is what you fill in. So once you've figured out which part of this should be u and which part should be dv, we need to figure out what du is by taking the derivative, so that's 1, and what v is by taking the integral. The integral of cosine is positive sine. You don't need to put the plus c here. We're going to save the plus c to the very end. Now we're going to fill in this side of our formula. So u is x, v is sine x, minus integral of v du. What we need to do to finish this is x times sine x. You can't do anything with. You especially cannot put those x's together and say that this is sine x squared. Anytime there's something inside of a sine or cosine or tangent or whatever, you can't put something from the outside with something inside. It's not how that works. So then we just need to integrate this. The 1 here, like if you do sine x times 1, that gives you sine x. And so that 1 didn't really need to be there. The integral of sine is negative cosine. And so since it's already negative, and we said it's negative cosine, that's going to switch it to positive cosine. Plus c, because we're at our answer. And our answers for integrals need plus c. This is going to be really similar in this problem that has sine instead of cosine. So du is going to be 1 dx. V, this time the integral of sine we just said a second ago was negative cosine. We're going to fill in u is x, v is negative cosine, minus the integral of negative cosine x times 1 dx. And so x times negative cosine x, that's not subtraction, that's multiplication. So we move the negative in front, and that's about it. There's a property with integrals where you can move the negative outside the integral, and since there's already a negative there, we're going to say that those cancel each other out. Basically, it's like a change situation, or click or whatever you do to remember that two negatives make a positive. Then we want to know what the integral of cosine is. The integral of cosine is a positive sine. So this is plus sine x plus c. All right, 2 more. We've got e to the x, and so we do du and get 1. We do v, which the integral of e to the x is just e to the x. We fill in our formula, which is u v, so x e to the x, minus the integral of v du. And so, again, this times 1, that part's not really going to matter because 1 times e to the x is still e to the x. So what we want to do now is say, well, what's the integral of e to the x? Oh, that's e to the x. And so since this has an x and this doesn't, those aren't like terms, so they don't cancel out, if that's what you were thinking. And finally, the derivative of natural log of x is 1 over x. And again, you either have to have that kind of stuff memorized, or hopefully your teacher's nice enough to let you use a formula sheet if you're not interested in memorizing, but sometimes we don't really have a choice, so you either have to have that memorized or use a formula sheet. The integral of x. Now we've done the derivative on the 3 previous problems. The integral of x is x squared over 2. So that's different than what we did before. We're going to write this out. U, which is ln of x, times v, which is x squared over 2, minus the integral of v, which is x squared over 2, times du, which is 1 over x dx, which I forgot to put the dx up there, but it should be there. ln of x times x squared over 2. Just like with sine and cosine, this x and this x cannot come together and make x cubed. The best we can do is write x squared over 2 in front and then put ln of x next to it. Here, though, we can actually simplify this integral. If you can, it makes it way easier if you look at this and say, oh, x squared over x, that's just x, because an x cancels. And I'm really good at Algebra 1, so I know that, and I've been doing that for years now, but the over 2 part of that has to stay there. When I integrate x over 2 dx, that's like what we did up here, except there's a 2 on bottom already. So think about it. If I have x over 2, and I add a power that puts 2 up here, and then that means I'm having to divide by that power, which is 2. So what we're doing is dividing by 2 and dividing by 2, which together means that we are dividing by 4. Another way of thinking of it is that when we divide, we flip what we have. So this is 2 over 1, so we're flipping it and making it a half, which means that those multiply together and give you 4. So the integral of x over 2 is x squared over 4. And the front of this stays the same. We put a plus c, and that is our answer. Hope you've enjoyed this review video. Have fun studying, or whatever.